Mas Marli. Jadi kita tinggal nunggu waktunya, timingnya saja ya.
Ya Pak, seperti yang tadi Pak.
Pak Ali stay di Rokan atau di Jakarta, Pak?
Di Rokan Pak Dedi, ini dari Duri ini Pak Dedi.
Oh, dari Duri. Berarti
Betul,
sama Mas Yusuf ya?
Mas Yusuf nih kebetulan dekat dengan ruangannya di Mas Yusuf ini.
Oke.
Kenapa Pak Dedi dengan Mas Yusuf? Mas Yusuf Hermawan kan ya?
Masih. Iya, sering diskusi.
Oh, mantap Pak Dedi. Makasih Pak Dedi.
Ya. Ali.idham.
Mohon maaf, silakan.
Sorry, Ali.idham, Pak Ali.idham SKK atau
PHR ini.
PHR Pak Dedi, mohon maaf.
Oke, baik. Saya coba dry run kali ya. Seperti sesuai sarannya Mas Fajri. Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone. Welcome to the joint convention Bandung Technical Session 2021. My name is Dedi Iskandar from Pertamina Hulu Energy, subholding upstream. Presently, I'm in charge to developing of asset integrity management system in subholding upstream. Today, this afternoon, I'm going to share this session with my colleagues. Please.
Hello everyone, my name is Marli Lesdi and I'm from SKK Migas production facility. Today I will become as a co-session chair.
Thank you, Pak Marli. This afternoon we will have 3 interesting papers covering operation and integrity management system. This presentation will be delivered by first presenter, Mr. Ali.idham from Pertamina Hulu Rokan. And the second presenter, Mr. Ekha Panji from Achmad Yani University Bandung. And third presenter, Mrs. Esi Marlini from Medco. Oke. Pak Fajri, apakah memang akan ada copyright notice? Nah, silakan Pak Marli.
This is a reminder to all the participants that no part of this content may be reproduced, stored in a retrieval system, or transcribed in any form or by any means, electronic or mechanical, including photocopying and recording without the prior written permission of Hagi, Iagi, Iafmi, and Iatmi. As a participant, we'd like to see you to be proactively participated by asking question or comment during the presentation. Please address clear and related question only on Q&A chat box. And I remind again, please respect copyright by do not take any recording and screen capture from any kind of devices.
Okay, let's begin with the first presentation. The first presentation will be about pipeline maintenance program with the paper number GCB 21-310. This presentation will be delivered by Mr. Ali.idham from Pertamina Hulu Rokan. And okay, let's hear and watch the presentation from Mr. Ali.idham. Screen and time is yours, Mr. Ali.
Pak Dedi, Pak Marli, apologies, sorry, the presentation will be automatically by audio, but we cannot hear the audio.
Mbak Ayu, Mas Fajril.
I think when Pak Dedi shares, Pak Dedi or Mas Fajril share screen.
Oh, berarti dari saya yang akan share screen.
I don't know, Mas.
Oh iya, sorry.
Ya, Pak Ali.idham, seharusnya yang share screen nanti dari Mbak Ayu. Nah, jadi setelah saya bicara time is yours, harusnya Mbak Ayu langsung on kan play si PPT ini kan.
Ya, kemudian Mbak Ayu ininya akan ini ya, langsung yang kalau dari itu Mas Fajrul informasi langsung dari ini ya, PPT recorded atau saya present di sini, Mbak Ayu?
Iya Pak, sudah dari saya. Mohon maaf tadi saya lupa untuk share soundnya. Ini sudah bisa Pak.
Baik. Kemudian yang pertama tadi mohon maaf Mbak Ayu kalau boleh SKK migasnya nanti saya diprotes Pak Marli kalau saya SKK migas. Menjadi Pertamina Hulu Rokan Mbak Ayu.
Jadi yang benar ini kan ya Mas Ali PHE Hulu Rokan kan?
All thank you to the committee for the opportunity to present the paper in this joint convention Bandung 2021 event. Let me introduce myself. My name is ali.idham. Currently, I work in PT Pertamina Hulu Rokan. I represent the team to deliver our paper. The title of paper is Comprehensive Pipeline Maintenance, sorted as a CPM program. A CPM program is Comprehensive Pipeline Repair and Maintenance Program in Rokan Block, was initiated in 2017. This is a collaborative paper written by Pak Aswandi and Pak Aristo Delmayuzar from SKK Migas, Pak iqbal.ruswandi from Chevron Makassar Limited, and myself, ali.idham from PT Pertamina Hulu Rokan. The presentations will contain 5 sections. The first is introductions, specific problem, a CPM program, CPM execution, CPM improvement or the result of CPM, and the conclusions. As introductions, the Rokan Block is one of Indonesia's largest crude oil producers. The Rokan Block produces approximately 75 active oil fields consisting of 3 major oil fields, Induri, Minas, and Makassar. There are 2 types of oil productions, heavy oil and oil light. The pipeline is used to transport oil production from wells to gathering station for separation between oil, sand, and water. Rokan Block operates and maintains over 530 kilometers of oil main shipping pipelines, and we call as main corridor in these presentations, to transport crude oil from the producing field to the Dumai terminal tanking facility. The existing main corridor pipelines were constructed more than 45 years ago, located above ground with no community around the area. But the current condition reveals that there are many pipeline segments that have partial or fully buried without proper coating and cathodic protection to prevent corrosions. As shown in the slide, the table shows there are 8 segments of main corridors, and then the pictures shows the schematic diagram of Rokan Block main corridor pipeline. A specific problem discussed in this paper there were pipeline integrity and operational issues in the main shipping lines. The first is aging pipeline networks. The pipeline is more than 45 years old, as stated before. And the second is heavy metal loss due to external corrosions from environmental and soil contact. The third is illegal road crossings. And then another problem is pipeline incidents from public road proximity and natural factors, and then from landslip, voluntaries, and erosions. As part of further pipeline integrity problem, inline inspection or ILI and long-range ultrasonic testing or LRUT were conducted on the existing aging pipelines to be used as baseline data. The results indicated some pipeline segments were at high risk due to significant metal loss. We can see in the picture some condition of main corridors pipelines. The pipeline leak due to illegal road crossings, corrosions, and also encroacher house or facility near to the pipeline. With the problems described in the previous slide, by considering the inability to perform full pipeline replacement during the remaining time of Rokan PSG at the time, the Rokan block operator was deploying comprehensive pipeline maintenance or CPM program, which covered all aspects of pipeline maintenance, starting from the inspection program, lifetime analysis, priority ranking, and planning to executions. The main goal of CPM program was to maintain pipeline integrity in acceptable level of services. The program was focused on activities related to the increased rate of proactive repairs by slipping program, and then perform road crossing repairs and coating applications, and then install sacrificial anodes and other interim mitigation until pipeline are either replaced or shut in. As part of CPM program, the Rokan block operator utilized Pipeline Integrity Management System or PMIS and implemented risk-based inspection tools to prioritize the asset integrity program. The picture in this slide shows the pipeline integrity flow process to maintain the pipeline integrity. The main integrity pipeline activities are, we can see in the slide, risk assessment, inspection, monitoring and testing, integrity assessment, and then mitigation and repair. This section will describe about the CPM program executions. The CPM program was initiated in 2017 to allow safe pipeline operations, reduce risk of loss of containment, and reduce the risk of social and environment impact due to pipeline integrity during the operations. Detailed objective of program activity, the repair criteria, and highlight result related to each CPM program activity will be discussed detail in these sections. The first program is pipeline repair by slip installations. The objective is to maintain or improve maximum allowable working pressure or MAWP that support safe operations. The repair criteria is to address the red and orange anomaly based on the projection of latest inspection result. We can see in the table the pipeline anomaly criteria based on the metal loss condition and MAWP. An example, the pipeline spot is categorized red anomaly if the metal loss is higher than more than 80% and MAWP is less than 1.1 MAWP limit. Total installed slip from 2018 until 2020 are around 4,600 spares. It's equal with 1.7% of total main corridor length. And then this is some pictures of slip installation activity. The second program is road crossing improvement. The objective is provide protections against external load or impact on illegal road crossings with the criteria based on the on-site visual inventory for 5 conditions, and then also the HCA, high consequence area class. The total road crossing improvement by installation slip reinforcement and cathodic protection with proper backfill are around 1,500 HT spots. It's equal with 3% of total main corridor length. This is some pictures show the comparison before improvement and after improvement. The third program is coating application. The objective of coating is to provide protection against external corrosion and mitigate corrosion growth. The repair criteria is based on the projection of inspection result on the buried or half buried pipeline with 50 until 60% metal loss. Total coating application and sacrificial anode installed until 2020 is around 20 kilometers is equal with 6.2% of total main corridor length. This is the picture of the coating application activity in as part of the CPM program. The next program is guardrail installations. The objective is to provide the protections against pipe hit incident due to vehicle traffic. The repair criteria is criticality prioritization based on the past incident, road condition, and pipeline positions. Total installed the guardrail until 2020 is around 30 kilometer guardrail. The picture shows the comparison between before improvement and after improvement. If no guardrail, the truck hit the pipelines, but the right picture shows that because of the guardrail, so the truck not hit the pipeline. And then the next program is sectional replacement. The objective is to replace the red and orange anomaly segmental pipes. The repair criteria is permanent repairs to replace the previous temporary repairs like watermelon, slip, and also slip over slip. The second criteria is environmental or constructability constraint and other technical matters. In example, to repair the anomaly pipes under public national road. And then another criteria is long anomaly pipe conditions. These sections will summarize the accomplishment of CPM program from 2018 until 2020 in ensuring safe pipeline operations. MAWP more than MOP, maximum operating pressure, and then the success to extend the pipeline remaining lifetime. To reduce the damage rate from pipe hit incident and to reduce lost production opportunity and increase mean time between failure or MTBF. The first is we can see the CPM program success to maintain MAWP above the MOP to support safe pipeline operations. After the CPM program, all of main corridor segment demonstrates MAWP improvement in 2019 if compared with the projected MAWP without CPM program. In addition, degradation of MAWP below required operating pressures due to aging pipeline has been avoided. From the picture of the main corridor anomaly mapping, we can see the reduction of red and orange anomaly in main corridor after the CPM program. The CPM program also success to reduce the pipeline failure due to integrity issue. To reduce the frequency of leak incidents since 2017, around 20% annually, and improve MTBF and mitigate decline rate in 2019 until 2021, and reduce oil spill incident and mitigate spill volume increase. This graph shows some result and successful of CPM program. The first is more flexibility in mitigating congeal event resulting from sustained MAWP, and then we can see the reduction of lost potential oil due to the congeal, and then the right picture show the reduction of number of damage inflicted to the pipeline resulting from vehicle strike or accident, and also reduction of associated repair costs resulting from the 5 hit incidents. This is the conclusions. As conclusion is the execution of CPM program in main corridor from 2018 until 2020 has successfully maintained pipeline operation at safe margin MAWP more than MOP. maximum operation pressures, and then extend pipeline remaining lifetime, reduce damage rate of pipeline heat incidents, and reduce lost production opportunity and success to increase mean time between failure or MTBF. The CPM program provided fit for purpose solution for aging pipeline condition given the condition of end of Rokan concession if compared to complete replacement with the following specific advantages. First is significant capital cost savings and converted into operational cost, minimizing social risk and increase the safety factor, and preventing lost production with an even greater effect, and generating baseline improvement with good learning for future activities. That's all our presentations. Hope this paper will give valuable knowledge as one of the best practice to maintain the aging pipeline to keep safe operation and the productions. Thank you from us and apologies if any mistakes. Thank you.
Okay, it's great presentation, Mr. Ali. Let's continue with the question and answer. If anybody has question regarding the material presentation from Mr. Ali, please, Pak Ekha Panji.
Okay, thank you, Pak Dedi and Pak Ali.idham for sharing knowledge about the pipeline maintenance. But I want to ask about why the Pertamina Hulu Rokan choose the methodology by using MTTF and MTBF, I think, at the method for applied in the pipeline assessment. I think for the actually many method in the pipeline maintenance strategy, but maybe for typically we reference to like a pipeline integrity management system at the slide. I also see from the DNV methodology, but how to predicting by using the MTBF. Thank you, Pak Dedi and Pak Ali.idham.
Okay, Pak Ali.idham, please your answer the question from Mr. Ekha Panji.
Yeah. Thank you, Pak Ekha, for the questions and the opportunity, Pak Dedi. Yeah, MTBF is one of only one of the indicator to know the success or know the program, the repair program we execute. This is the another MTBF. There are another indicator like LPO, loss potential oil, and then another. But the problem is we want to know what is the impact of the repair program to the leak event, because this is the aging pipeline. We know that from before the CPM program, we have some historical record that there are a lot of events in the pipeline because of the metal loss is heavy loss metal loss, and then we repair with the sleeve, with the coating and the graph. If we can if we see in the paper from the graph, there are increase for the mean time between failure. We want to know, for example, in before the CPM program in 2016 or 2017, every 5 days there are leak in that pipeline. But we address the red and anomaly pipelines based on the inspections. We conduct the sleeping program and then another like sectional replacement and other. We analyze. In 2019, the MTBF is increased. So the mean time between failure, mean time between the leaks in that segments is increased. For example, in previous before the CPM program is 5 days. But after the CPM program, 30 days or 45 days, the time between the failure. That's only one indicator we want to know. What is the impact of this pipeline repair? That's hope it answer the question, Pak Ekha. Thank you for the.
Thank you, Pak Ali.idham.
Okay, thank you. Is there any question from the other presenter or Pak Marli?
Maybe one question, Pak. For this pipeline maintenance, what is the major difference before the previous maintenance strategy that held by previous company? I mean, before this compression pipeline maintenance, although the strategy for the pipeline maintenance, what is the main difference actually?
Thank you, Pak Marli, for the questions here. The difference is the previous operator conduct the dedicated team to collect all the pipeline program in one team. So the comprehensive, and then starting from the integrity until the execution. So the difference is the number of repair is significant, Pak Marli. But previous before CPM program is there are also pipeline maintenance, but the CPM program is led by the previous operator cannot replace the pipeline due to some non-technical issue, and then because of this is the critical pipeline, and then we need to repair. So the first objective of CPM program is to address the main corridor because of that reason in before the end of concession, Pak. So there is no difference significant repair program, but the number of repair is significant to address that recent issue, Pak. Thank you, Pak Marli.
Thank you, Pak.
Okay, thank you, Pak Marli and Pak Idham. I think unfortunately we are running out the time to the answer. Maybe if the participant or audience have a question, you can chat box or email to the Pak Ali.idham. Right now, I think on behalf of the Joint Convention Bandung 2021 Committee, we would like to thank you to Mr. Ali and the co-authors. And as an appreciation, we would like to hand over this memento, and it marks to the end of the first presentation. Thank you very much.
Okay. Izin interrupt. I will lead the documentation session of this memento. Thank you for Mr. Ali, Mr. Marli, and Mr. Dedi. Okay, for the first photo, 1, 2, and 3. Smile. Okay, for the first photo, the second, and then for the second pose, maybe 1, 2, and 3. Okay. Okay, thank you, Mr. Dedi, Mr. Marli, and Mr. Ali for the great session. And then I will return it to Mr. Dedi again.
Thank you, Pak Dedi, and
thank you,
Pak Marli.
For the next, Mr. Marli will be as a chairperson.
Thank you. Thank you, Pak Dedi, for the. Now we start the second presentation. The presentation will be about phenomena of scaling and corrosion on crude oil piping system. This presentation will be delivered by Pak Ekha Panji Syuryana, STMT from Universitas Jenderal Ahmad Yani. Without further ado, let's watch the presentation.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Ekha Panji Syuryana. For the presenter, phenomena of scaling and corrosion on crude oil piping system. with velocity profile in fully developed condition approach. Paper author for the main author is Dr. Insinyur Sutarno MT. He is formerly the senior engineer from Indonesian aerospace industry, and me, co-author or presenter, Ekha Syuryana, STMT, and you can add my LinkedIn profile for next discussion also. For daily, I am as a lecturer in Metallurgical Engineering Department, Faculty of Manufacturing Teknologi, University of Jenderal Ahmad Yani, Bandung. And the third co-author, this is Insinyur Mudzakkir Hasan Basri, MBB. He is a director from PT Dago Energi Nusantara, a consulting company in Bandung. Mapping interaction, pipeline and environment condition. This is we need to consider about the material properties like tensile, bending and compress in the load condition for the material. And in this condition, we know about if in pipeline or piping system, we need to consider about the LTCS, SMYS, and also the SMTS of the mechanical properties of material. And from the environmental condition, we also need to consider about the temperature, pressure, pH, K, the species of corrosive and scale. And for the fluid characteristic, also you can see in the picture in the beside, this is Indonesian crude oil and also the produced water sample at Pertamina Mudzakkir with this is a gathering from the many source of Indonesian crude oil, and this is from the pipeline system. And also we need to consider the fatigue and mechanical condition or like fracture, and the next also and the inherent defect in manufacturing, like we know, but if we see the steel making process, we know about the line pipe material. Also we need to consider about the micro laying element, and also the thermomechanically controlled process and the another process. And this is the chemical composition of oil. Also if we see about the gathering system and also the well system or the wellhead system, this is a many consideration in the different parameters. And also for the first, maybe if we see from the offshore platform like wellhead superstructure, and also the mobile operation production unit, also the floating production unit or another condition. This is the every condition. And also from the system facility for oil and gas production, this is especially for crude oil production. We also consider about the oxygen and also H2S, water and chloride species and another condition. For example, this is from the Migas field. The FPI gravity is 35.0 and the sulfur content is 0.80. And this is sourced from Indonesia, you know, maybe this is from area from Pertamina Hulu Rokan, I think. And this is a condition, and for example, and also from many countries. In this interaction for the K spaces I mentioned before, for the many characteristic of impurities, for the first from the oxyhydroxide, this is we can predict to the what the corrosion spaces with in this impurities. And also for the chloride, for making the FeCl2, and for the hydrogen, maybe we know this is oxyhydroxy type. And for oxygen, this is making the Fa2 or O3, and the H2S also, this is making the EVS, and this is lower temperature rather than basic of steel we know as Fe3C, and this is CO2 can form the FaCO2. And why these impurities can making this condition for the corrosion to in this piping or pipeline, for example, many type of impurities can make the defect or damage in the piping or also in the pipeline or actually in the mechanical static equipment also. For example, I mentioned this hydrogen sulfide. This is have the many characteristic of cracking. For example, I have found for type is stepwise cracking in the Indonesian pipeline section. And also, this is many type of other corrosion at the due to the characteristic of external environment, also from the internal environment. This is for detailing illustration I captured from my other presentation. This is a characteristic for why the impurities can give the defect or corrosion effect. For instance, this is we split to or divide to characteristic. For the first is sour corrosion. This is described to problem with hydrogen sulfide, and this is sweet corrosion to describe corrosion by CO2 corrosion. For the first, if we have found the impurities from H2S can affecting to the pipeline body and from the internal surface, and give the reaction, the first making the EVS and the second one is EVS2. And this is a different characteristic, and also they give the cracking effect to the pipeline body between the internal or external surface. And the CO2, the sweet corrosion, in this form of a reaction, the CO2 can making the reaction with Fe or ferrous material in the pipeline or the internal surface of piping or pipeline, and reaction with making the type of one of a corrosion product. This is FaCO2, FaCO3, and this is the characteristic of sweet and sour corrosion. Reaction electrochemical I have mentioned before about from the impurities of H2S. This is a detailing of the chemical reaction. Also for CO2 and combine about the CO2 and H2S. For the first, I give this is illustration about what can H2S doing to the pipeline or the piping. This is characteristic of different between the period marcasite and machina with aggregate or the another type of the reaction between H2S to the pipeline body or pipeline material. For instance, this is machina with FAS1 or FAS2 have the characteristic of the crystalline characteristic. Maybe if you know about the metallurgical engineering, this is different of unit cell characteristic, also different in hardness characteristic. Different in hardness characteristic, also the characteristic of corrosion in the surface of pipeline or piping system. And for the illustration of another impurities for CO2, this is we can predict. I capture or citation from Robert Heidelbach, Metallurgy and Corrosion in Oil and Gas Industry, 2011. This is a curve can help to if we in the basic phase of engineering or basic design of engineering. This is a very helpful diagram for predicting how the effect of corrosion rate by the CO2 impurities in system crude or gas or iso gas. This is the reaction of electrochemical from the CO2. We can calculate manually, and also you can using this formula from Norsok 506, and this is for consideration. We predict the CO2 fugacity and for the calculating for predicting the corrosion rate in MMPY. This is the illustration for crude oil characteristic. If we use a figure, we can see detailing like this, and in our campus also we make this as a closed flow loop system for testing the flow characteristic and corrosion damage mechanism to line pipe material. We call the closed flow loop system testing. And this is what we get from the corrosion flow loop testing in our labs and our corrosion labs. This is if we know about the development characteristic of flow. We see in the center of pipeline or piping, the velocity is optimum. And near to the surface of piping of pipeline, this is the velocity near to zero as the formula by the fully developed region. This is the characteristic and formulation, but the visualization, the center is actually rather than the velocity is higher rather than the surface of the pipeline or piping system. Actually, with that condition, maybe the scaling tendency higher potential at the surface of the pipeline rather than the center of the pipeline or centroid of the pipeline internal. And this is many picture if you get from internet. This is the many characteristic about the piping or pipeline bagging. And this is maybe we need the requirement about cleaning peak, bi-die peak for cleaning this condition, but different, slightly different from the geothermal pipeline system, because the geothermal pipeline system is don't have pitching equipment or peak launcher or peak receiver as in the gas or the crude oil pipelines. This is the basic formulation for we calculation how to consider the total case basis characteristic, and also in this calculation also we need to consider about the Reisner or Langmuir saturated index for consider the water condition. And this is the formulation for predicting about the fluid flow condition and profile velocity, and we can get the tendency of the scaling formation or tendency to corrosion formation. Okay, this is an example for the case basis or scale corrosion. We have many type in here, and maybe you can find if you see from the labs data from the provider of lab, if we have the sample fluid from the well, we have the characteristic and also the quantity or percentage of the case basis and potential to give the effect to the surface of the pipeline or piping system. For oil flow characteristic, we have discussed before. This is from the piping system, also from the fluid velocity and process parameter. This is the three of we consider to calculate the total case basis. Based on I described before, maybe this consider for the especially for crude oil. We know we use the SME B31.4, and this is the comparative for effect the surface roughness with the characteristic of many impurities I mentioned before. This is case basis have the effect to deposit in the characteristic of surface roughness. In our research before, we compare for the API 5LX65 grid 80 and the surface characteristic from grid 800, and also the superfine foliage. This is the characteristic of surface corrosion product. I have a test with the team using the corrosion flow loop system. And this is the conclusion. We know the effect of the fully developed velocity and the slow velocity at the surface of the pipelines. And this is the reference. Thank you, everyone.
Okay. What a great presentation and very comprehensive from Pak Ekha. Now let's we continue with the Q&A session. If there are any participant who would like to ask the question, please write down on the Q&A section, or maybe from the presenter. If you want to ask Pak Ekha, Panji, please let me know. And while we are waiting for the question, there's something I would like to ask to you, Pak Ekha. I read the presentation and the paper. You mentioned it, the velocity of the system is zero when it develop in the fully developed condition. What it mean by that? Is it the fluid is stagnant? And how we can mitigate that, Pak? As I see in the presentation, it seems that only in the middle of the pipeline that's flow, if I'm not mistaken, but the outer is stay. And how we mitigate that, Pak? Thank you.
Okay, thank you, Pak Marli. And in these models, we know about by the scientific model, we assume this condition, if fully developed, the condition with the near water from the surface of the pipelines or piping, this is near to zero. This is actually in this condition, we be careful about the surface characteristic of the line pipe. We selecting for the project or for the pipeline or piping, and this condition about the fully developed characteristic of fluids. In this condition, we also be careful about the mitigate to microbial induced corrosion, also based on this characteristic model. But for the mitigate, maybe in many field of oil and gas exploration, maybe can choose the mitigate by scaling inhibitor, or also if we tendency to corrosion, we also use the corrosion inhibitor. This is to program for mitigation this condition. But actually, from the many characteristic of offshore or onshore pipeline is slightly different. For the sample, if many different for the inclination characteristic, this is also we need to use the another prediction model by using ICDA. But this is many models, but actually in the field, maybe we need to simplification of the formula, but this is a basic formula for analyzing if we predict the scaling tendency or corrosion tendency. This is I answer, Pak Marli. Thank you for the answer for the question.
Thank you, Pak Ekha, for the answer. Maybe Pak Dedi, do you have any question for our presenter?
Yes, thank you, Pak Marli. Pak Ekha, good presentation. I think is comprehensive material. Just simple question, I think. Based on your research, Pak Ekha, how about the sensitivity of the parameters? I mean, which one the most sensitive parameter? Like, for example, if it's pH, temperature, impurities like CO2 or H2S, or roughness. Which one the most sensitive?
Okay. Actually, for the predicting the characteristic, the mostly the parameter is the pH, Pak, the acidity or alkalinity of the crude oil. From that, we can predict separately. I mentioned in our slides. Also, we split the characteristic sour or sweet characteristic. This is a main concept about predicting on scaling or corrosion tendency by the alkalinity or acidity characteristic of the fluids. And the second one is temperature, and the third one is the velocity. Why? In if we want to know about the maybe I mentioned about the characteristic of inclination effect. Also, if we have the different topography or bathymetry in our pipeline or piping system, also the different but the high condition or the elevation condition. This is also have the characteristic of tendency to scaling or corrosion characteristic. But for the characteristic of acidity or alkalinity, we also required in flow assurance study, Pak Dedi. Maybe this is a simple answer for us.
Okay, I think
Yeah.
clear enough for me.
Yeah,
Thank you,
Pak Dedi.
Thank you, Pak Ekha.
Thank you, Pak Dedi, Pak Ekha. Unfortunately, we are running out of time. But don't worry, if you have any question, please write down the Q&A box, and Pak Ekha will happily answer the question. And you could contact also Pak Ekha in the LinkedIn that already shown before.
Yes, thank you, Pak Marli.
Okay, on the behalf of Joint Convention Bandung 2021, we would like to thank you, Pak Ekha, and the author and the co-authors. As appreciation, we'd like to hand over this memento, and it marks the end of the second presentation.
Okay, I will leave the documentation of the memento session. Okay, 1, 2, and 3. Wait a second. Okay, one more with the different pose. 1, 2, and 3. Okay, thank you very much, Pak Ekha. Great presentation. Thank you very much, Pak Marli, Pak Dedi, and I will return it to Mr. Dedi.
Okay, let's continue with the third presentation, I think. The third presentation will be about unlocking potential through effective planning and scheduling with the paper number GCB 21-312. This presentation will be delivered by Mrs. S.C. Marlini from Medco. And without further ado, let's watch the presentation from Mrs. S.C.
Unlocking potential of brownfields through effective implementation of planning and scheduling. Good day, everyone. I am S.C. Marlini. I am the author of this paper, and please meet my co-author, Dipta Dwitya. Today, we will take you through our journey of how we implemented a planning and scheduling system to ensure we can operate our brownfields as effective and as efficient as possible. Please note the 4 keyword system: brownfields, effective, and efficient. We will talk you through the context, which is how brownfields have very small room for error. And then the content, how we use operational excellence and how we identify the 10 critical elements and the 5 C's for building a powerful coalition. And then we talk about how all our efforts have contributed to the company's goals and objectives, and how we build a strong governance and a really solid network of people taking care of our planning and scheduling. Finally, we will wrap up with the conclusion of the key learnings, especially about how we identify the critical elements. We focus on developing people and how we build cadence of accountability through MPRPs. First keyword, brownfields. Now, brownfields or mature fields, low productions, and sometimes, most of the time, stubbornly high operating costs. Therefore, there is very narrow room for error. Usually, this high effort with relatively low return. Decisions need to be made swiftly and accurately. We don't have the luxury of time with brownfields because the field might just die within a couple of months. So we need to have really accurate strategies and work methods. In terms of system, a system must have a framework. Let's take this for example. Our house, our home, our households. We need to have 4 pillars. We need to keep our family safe, healthy, and also our surroundings in a good condition. We must then keep the house in a good condition, no leaks, no hazards. All our equipment and utilities must be taken care of to maximize reliability. Finally, all our efforts must be planned and managed to help us achieve the best possible outcome. This talks about how we use, how we make money, and how we use them. So basically, this is the framework of operational excellence, which is the key to operational excellence. Achieving operational excellence requires systems, systematic approach, and therefore we have the 4 pillars. HSE, health, safety, environment, which is always important. Then ANOI, asset and operating integrity, cost management, and finally operating efficiency. Our focus in this paper, in this presentation, is on operating efficiency, which inside is there are production monitoring and optimization, maintenance and reliability, and planning and scheduling. Now, achieving operating efficiency to effective planning and scheduling, there are 16 critical elements that we have for this focus. As we are in the early stages of building the system, we have identified 10 critical elements, and these 10 elements are divided into PDCA cycles: plan, do, check, and adjust. In the plan stage, we are planning and scheduling philosophy, which is the basic way of thinking, a simple one-liner that governs everything we do in planning and scheduling. It goes a little like this. All our activities are planned and scheduled in a way that help us achieve the best possible outcome. Simple philosophy, but very powerful. Then we build the governance and we ensure that there are clear roles and responsibilities. We then need to set up the planning tools, planning components, and we need to have a standardized way of inputting the plan. In the do stage, we focus on planning horizons, long-term, medium-term, and short-term. And then we also covered planning and scheduling communication, how we communicate our plans and schedules, the meetings, the documents, how is it circulated, how it's distributed, and also plan visualization. What is being distributed? How do we convey this? Is it a spreadsheet? Is it a report? Is it a document? Slide pack? That's plan visualization. And we want to go to check stage. Plan performance, which talks about how everyone is in compliance to the planning. And then we focus on key performance indicator, KPI, because we always need to measure our performance. And finally, in the adjust stage, we look for ways to adjust our planning program to continuously improve our planning. So as we talked about earlier, this is the content, which is the 10 critical elements. Now let's move on. What we discovered to be the most important aspect of building a system, which is focusing on the people. Now, how do we build a strong guiding coalition, strong team, and how we use 5C framework to do this? The first C is care. We need to care about what we are doing here. We need to care about the people. We need to care about the things we do. As far as we build trust through connecting with people. And next question, how do we connect with people? We do that by spending quality time with them, with the managers, and of course, with the planners. We do informal support dialogues and sessions. And after that, we create clarity by managing expectation and providing knowledge. How do we provide knowledge? What we did was we created instructional videos on oil and gas operations because that's always important. And then we show commitment. We don't demand commitment. We show commitment by providing continuous support. We do one-on-one checkpoint with asset planners. We provide them guidance and we help them with whatever their concerns and their needs. And behind the scene, we also communicate the asset planners' expectation with the operations managers, their managers. Engagement and ownership come from having a sense of control. So we do that to create a peace of mind. And that's what we try to achieve by showing to trust, to receive connection, clarity, commitment. And finally, we continuously improve by creating a collaborative environment. Coming together as a beginning. Staying together, that's the progress. And working together, that's success. So this was the framework we used to focus on the people. Let's come to this. What does planning and scheduling look like? I give you a simple example. Say we have a goal of producing 100,000 barrel oil equivalent BOE per day on average for this year. So we have a plan to achieve that. We focus on three aspects to help us achieve that. Well works, maintenance, and HSE. And each we have three activities. We will install 20 ESPs. We will perform 4 workovers. And the last activity for well work is we will convert 6 new water injection wells. And then in terms of maintenance, we have 1 shutdown maintenance, 8 general overhauls, and 1 general inspection. In terms of HSE, we aim to get a proper green. So we take care of the document and everything that is required for it. And we try to limit our operations to under 100 tons of greenhouse gas. We will also perform 2 area safety meetings. So from that plan, we create a schedule from medium term, 12 months, all the way down to short on 30 days and even weeks. And we maintain cadence. We maintain a good rhythm through our MPRPs, monthly performance review and planning. This is crucial. This is where we make sure everyone understands where we are at, what we need to take care of, what we need to do to put our efforts on, what we need to address, and the issues that we need to manage. By doing this, we create contribution to company in terms of achieving organizational goals and objectives. Despite COVID-19, of course, limiting mobility of personnel, and all these effects and shifts in both short, medium, and long-term plan, we also contributed by establishing strong governance through developing a comprehensive guideline on planning and scheduling, which is consistently implemented organization-wide. We also developed 12 planners who are the heroes of our planning and scheduling efforts. And in the process, we created a strong collaborative community focused on collective and continuous improvement. Finally, our key learnings. Whenever you want to build a system, you need to first identify critical elements. Take some time to learn and identify the most important elements for the early stages and never ever ignore focusing on developing the people. Always start there. We don't try to manage them, we develop them. When we develop people, it creates more engagement and more ownership. Because, guess what? All these things are that we are doing the system, the governance, understanding that will be executed by the people. So let's focus on that. And finally, always have a way, a method to keep cadence of accountability. Keep a solid rhythm of accountability through periodic checkpoints. Review our performance and plan how to keep on improving, how to be better. Overall, that was our journey, how we implemented a planning and scheduling system to ensure we can operate our brownfields as effective, as efficient as possible. Thank you for your kind attention. Hope you have a very enjoyable day and you keep inspiring. Stay healthy and stay happy. Good afternoon. Unlocking potential.
It's excellent presentation, Mr. Esi. Thank you. Let's continue with the question and answer. Let me check in the chat room. Is there any question from the floor? I think, okay, is no. Maybe from the other presentation or other presenter, you have question, you can raise hand or say something in the directly to the Mrs. Esi. Please. Okay, if there's no question, Mr. Esi, I would like ask a few question from your title, Unlocking Potential of Brownfield. For the first question is, what is the most difficulties to implementation of effective PS?
Okay, what is the most challenging?
Yes.
Right? Okay. There are a lot of things actually, but first we focus on the people, because if we can say that we have good guideline, for example, we have very powerful tools, for example, but if we don't have people, we can't run all of them, right? So that's why we spend most of our times to equip our planners. Actually, we have some people who help us from each asset. So we call them asset planners. We spend most of time with them. So if you ask me about what is the most challenging things, it's about managing the people.
Okay.
Okay. Thank you, sir.
Okay. The second question.
Okay.
The second question is I'm interested with the continuous improvement cycle, PDCA.
Okay.
Okay. The especially for adjustment. How you manage the planning adjustment program?
Okay. How we manage adjustment program? As plan change, right? So we manage them by, for example, like this. If the condition on the field cannot support our plan, so we have to make a change. So for example, here we, for example, functions or maybe sections who owns the activities because of something. For example, there is no budget or maybe there is no cost to support the activities, or so what is they propose it to the operations managers. Here we have operation managers who is responsible for the activity. So we have a form, sir. We have a form. In this forms, we have the justification. Actually, the justification why this plan change. Why should we change this plan? Because as we know that we plan this activity in early year. To achieve our target, right? So if we cancel or maybe if we change not cancel, if we change the activity, so it will impact to our KPI, right? So that's why the justification is should be very strong. If it's related to the cost, if we can find what is other budget source, so we need to make adjustment. Is it clear enough, sir? My answer?
Clear enough for me. Thank you, Mrs. Esi.
Thank you very much, sir.
Yeah. Is there any question from the other presenter or Pak Marli? Do you have question to Mrs. Esi?
Actually, I have the same question with you, Pak Dedi already asked.
Okay.
Okay, thank you. I think for this we have a time limitation regarding the question and answer.
Okay.
Maybe, but don't worry to the other participants or audience. You can chat or make a question by typing in the answer on the Q&A window. And then on behalf of the Joint Convention Bandung 2021 Committee, we would love to thank Mr. Essi and the co-authors. And anyway, as an appreciation, we would like to hand over this memento, and it marks the end of the first presentation. And thank you very much.
Thank you.
Basri?
Yes, Mr. Dedi, I will lead now the documentation. 1, 2, 3, and smile. Okay, for the first photo. And then for the second one, maybe with different pose. 1, 2, 3, and smile. Okay, thank you so much, Mr. Dedi, Mr. Marley, and also Miss Essie for the amazing presentation. I will return
Thank
it
you.
to
Thank you
Mr.
very
Dedi
much.
again.
Thank you very much, Mr. Dedi and also Sam Marli.
Okay, I think this the last presenter, Mr. Essi, is the completed this session. I think we can and say maybe Pak Marli regarding the jurnal Migas. Pak Marli, you can say something. Pak Marli in mute.
Sorry, Pak. Okay, I would like to inform to all the presenters that GCB 2021 will facilitate any presenters who keen to publish their paper in international journal. Please contact the show on the slide for detailed process. And also, we would like to remind you that we still have more fascinating session for tomorrow. For room 2, session 20, we'll talk about code and standard for oil and gas facility, started at 8 o'clock.
Okay. Thank you, Mr. Marley, for the explanation and information. I think for this session is enough and finished, and I think we would like thank you for the 3 presenter in here, and then thank you for Mr. Marley, and then Mbak Ayu and Mas Fazri. Thank you.
Okay, thank you very much, Mr. Dedi.
Thank you, everyone.
Okay.
Thank you, everyone.
Thank you very much, Mr. Marley, and all the
Thank you, Pak
presenters.
Dedi, Pak Marley,
you, you're welcome.
presenter.
Ya, Bapak Ibu bisa meninggalkan Zoom meeting. Terima kasih Bapak Ibu.
Terima kasih Mas Fajri, Mbak Ayu, terima kasih.
Terima kasih, Mbak Ayu, Mas Fadril.
Sampai ketemu lagi di next event, Mas Marli, Pak Panji.
Ya Pak Dedi, sampai ketemu lagi Pak Dedi.
Ya. Izin live saya. Assalamualaikum.
Wassalam.
Terima kasih Bapak Ibu presenter.
Makasih
Mas
Mas Fadri.
Ya,
Terima kasih Mas
Terima
Fajri.
Besi.
Izin
Yuk,
live.
Ya.
Terima
Mangga,
kasih
Bapak
Pak
Ibu.
Idham, Mbak Esi, makasih.
Makasih Pak Dedi.
Terima kasih Bapak Ibu presenter, Pak Dedi.
Salam sehat. Bye.
Ya Pak.